Okay, here are solutions for quiz 2 for Math 211. The first problem says that on the first day I give you 1 penny, and each subsequent day I give you 2 more cents than I gave you the day prior. Okay. And what makes it challenging is it asks about how much total money have you received from me after 100 days. So not how much money did you receive on the 100th day, how much total money had you received by the end of the 100th day. So I think probably the easiest way to do this is kind of look for a pattern. So maybe I'll make some columns day, maybe money, pennies, cents, I don't know, cents, I guess. Cents that day, and then total cents received or something. I before E except, I think that's right, received, whatever. So let's see what happens here. Make these 3 columns. On the first day, says I gave you 1 cent. And since it's the first day, that means the total is just 1. On the second day, I gave you 2 more cents than I did on day 1. So 2 more than 1 is 3. And so now the total amount that I've received is 1 plus 3, which is 4. On the third day, I gave you 2 more cents than I did on the second day. So on the third day, I give you 5 cents. And so now the total amount received was the 4 that you had before plus 5 more. So I guess that ends up being 9. And then on the fourth day, I guess that would be 7 cents. And so now the total you have is 9 plus 7. The 9 that I had given you before and the 7 new. So 16 total by the end of the fourth day. I'll do one more. On the fifth day, I guess that would be 9 cents, 2 more than I'd given you on the day prior. And so the total amount you had received was the 16 you already had and the 9 new cents, and you get 25. Maybe start to see the pattern here. Note the total amount given after day maybe n appears to be n squared. Maybe instead of is, I should even say appears to be. It is n squared. I can prove that to you, but for the sake of our class, what we decided is that when we're looking for a pattern, we'll just say it something like that. It appears to be n squared. So after 100 days, you received 100 squared cents. 100 squared is a 1 with 4 zeros after it. So 10,000 cents. And if I move the decimal place twice, I can get that this is $100. So the amount you've gotten, $100. There you go, nice round number. After 100 days, you've made $100. The reason this works, in case you're curious, when you're adding up odd numbers, you can kind of add up, there's 1, and then the next 3, instead of writing them like 3 in a column here, I'll order them kind of cleverly to make this little square. And then the next 5, I can tack on here, 1, 2, 3, 4, 5. And what you see is after each iteration, the next 7 will go here, the next 9 would go here, you have a perfect square. And so that's why you end up with this pattern that the total amount of cents received is n squared. Okay, moving on to the second one. Okay, there are 6 baseball games on tonight, apparently. If I only have time to watch 2 of them, how many different options do I have for my TV viewing? Note, this is the nacho problem. So for the nacho problem, there's a few ways we could do it. One way you could do it was by setting up Pascal's triangle. One way you could do it was by making a systematic list. So maybe I'll do it both ways. Why not? Systematic list. 6 games, maybe A, B, C, D, E, F. If I watch game A, I can also watch game B, or game C, or game D, or game E, or game F. That is, if I choose to watch game A, which I may or may not do, there's 5 choices that I can do. And if I focus on game B, well, I've already noted that watching games A and B is one option. So I guess I would say BC, BD, BE, and BF. So it looks like I got 4 choices, or options. And similarly, if you choose game C, well, I already got A, C, and BC, so I guess C and D, C and E, C and F. So there's 3. And then you got D, E, and DF, and finally EF. So it looks like the number of options I have is whatever 5 plus 4 plus 3 plus 2 plus 1 is. Could use Gauss. That doesn't say could. Try that again. You could use the Gauss method anytime you're adding up numbers from 1 up to n. The sum you can figure out using Gauss's method, but I wouldn't. Just add them up. Let's see, 5 and 4 is 9, plus 3 more is 12, plus 2 more is 14, plus 1 more is 15. So that's my answer. It's 15. You also could use Pascal's triangle. Maybe I should do this in a different color so these don't kind of bleed together. Or do Pascal's triangle. Pascal's triangle, I'll write out the first few rows of it. So the idea with Pascal's triangle is you start out with the 0 row, which is a little bit confusing. This is the 1 row, the 2, the 3, the 4, the 5, the 6. One of the many things encoded in Pascal's triangle is it tells you how many ways you can choose either 0, 1, 2, 3, 4, 5, or 6 from a group of 6, or 5, or 4, or 3, or 2. This 15 right here turns out that this shouldn't be in red because it's going to get confusing. In green, I guess. This tells me there are 15 ways I can choose 2 of the 6 games. So either way, whichever method you use, you're going to get the same answer. You're going to get that there are 15 options. For part B, it's actually the same question. Wait, how can it be the same question? Well, it doesn't look the same. It says if I only have time to watch 4 games, how many different options do I have? I thought we were just watching 2 games up here. How is it the same? Well, if you're choosing to watch 4 games, you can think about it as pick 2 that you won't watch. How many ways can you pick the 2 that you won't watch? Well, there's 15 ways. Here they are. You could not watch E and F, or you could not watch C and E. You could not watch B and C. If you think about these as the ones you don't watch, actually the same question, 15 ways shown above to pick the 2 games that you don't watch. And that's true. Or, maybe I'll even say, or use this 15. This 15 right here, it turns out, is the number of ways you can watch 0, 1, 2, 3, 4 of the 6 games. So either way, either you go back to Pascal's triangle and know that encoded in that triangle is this information, or you kind of make your systematic list, something like that. You get the same answer, it's 15. Finally, the last part of this problem. If I can watch as many as I want, how many options do I have for my TV viewing? Part C. Either add the sixth row, which is actually the seventh one down because we have that 0 row at the top of Pascal's triangle. Or, note, you have two choices, or you have two options. Either to watch or to not watch. For each of the 6 games. So what that means is you have 2 times 2 times 2 times 2 times 2 times 2. And that is 64. So 64 options. And you might note that if you add 1 plus 6 plus 15 plus 20 plus 15 plus 6 plus 1, you get 64. Here's 20, there's 30 more, that gives you 50. 12 more, that gives you 62. 2 more, that gives you 64. Anyways, the answer for part C, 64. I think I answered everything. So that's the end of this quiz. I'll stop this video.